whenever something is moving in a fluid, it will offer a resistance. It is similar to a drag force or air resistance. But generally, this formula we will be using specifically more towards the liquid part because air resistance is very less. The coefficient of viscosity is very less, but we can use it for gases as well. So that is why it is used for fluids, not only for liquids. But in our syllabus, most of the questions will be related to the liquids only. So it is nothing but, let us write it down, resistance offered by a fluid when an object moves in the fluid. So do not get confused with the buoyant force. Buoyant force will act whenever an object is immersed in the fluid, whereas viscous force will act if the object starts to move. If it is floating, then viscous force will not act. It only act when the object is moving through the fluid. Am I clear? And the formula, if you look it in the data booklet, if you have, it is written as F and then in a subscript small d is equals to 6 pi neta r v. This is the formula given. Do not get confused. This is my r. Do not get confused with pi. This is pi. This is r. Okay. 6 pi is a constant. This neta is called the coefficient of viscosity. Coefficient of viscosity. It is in Newton second meter minus 2. You can check. This is Newton. 6 pi is a constant. R is in meter. This is meter per second. So Newton second meter minus 2 will be the unit. Now this is only the property of the fluid. Like if you are in water, then coefficient of viscosity will be something else. If you change the liquid, let us say to vegetable oil, then your neta will be different. So it is only the property of, or you can say only depends upon the nature of fluid. If you change the fluid, then only it will change. Otherwise, for the given fluid, it will constant. Uh, Although it changes with temperature, but that too at a very huge range of temperature, but that we are not discussing it here. At normal temperature, it will remain the same. R is the radius of the object, radius of the spherical object. This formula is only applicable for spherical object, like a small ball or a sphere or something. In our syllabus, we are only dealing with spherical objects. It is only applicable for spherical shape objects. And that is why R denotes the radius of that in meters.
So it's only going to be spherical shaped objects that will be in the fluids
Yeah,
in our example.
yes. And V is the terminal velocity. I hope you know what do you mean by terminal velocity by now, right?
Yeah.
It is terminal velocity is the velocity, or you can say constant velocity at which it starts to move. Constant velocity where acceleration is zero. Or you can say the net force acting is zero. So always remember R is in meters, V is in meter per second, neta is the coefficient of viscosity. Most of the time it will be provided to you. Now, if let us say if an object, if I have a beaker, let us say like this, if I have a container and it is Let me make it properly. Okay. And there is some liquid filled in it. Let us say this is water filled in this container, and there is a spherical object. Let us say this there is a spherical object which is moving in this liquid with a terminal velocity v. Now it has radius r and mass is m. So if I ask you to draw the free body diagram, assuming it is lowering down with terminal velocity v, what would be its uh, what would be its free body diagram first of all? And then we will find out the terminal velocity v in terms of the given variables. To draw the free body diagram, I can simply say that let me draw a simple point. So there will be a downward force acting which is equivalent to weight, and there will be two forces acting in the upward direction. Either you can show with two different arrows, or you can simply draw one arrow and say FD plus FB. FD is your drag force and FB is your buoyant force. Do not forget about this. So if it is moving with terminal velocity, then simply I can state that the F net is zero because acceleration is zero, velocity is constant. So if this is the case, then I can simply say that Fd, which is drag, plus Fp, which is buoyant, is equals to my weight. Have you understood this equation? And let us say the density of the liquid is L, mass of the object is m, radius is r. The liquid has the coefficient of viscosity as neta n. Okay, what else we need? That's it. If it is equal, doesn't mean that it will not go down. It will go down with constant velocity. If an object is moving at constant velocity, it doesn't mean that there is no force acting. It simply means that the forces are balanced. It is like the same example as that of the parachute. A person falling with the parachute open and moving constantly down. It doesn't mean the weight
Yeah,
is not acting. Weight and air resistance
yeah,
both are equal and opposite. So this is a very common misconception among students. Do not get confused about it. Okay. So FD is what? The drag force, which is 6 pi neta RV, and buoyant force is rho L. As the object is completely immersed in it, the whole volume times G is equals to mg. Now don't get cancelled out this G because it is in addition and there is no G in this part. Okay, so G will not cancelled out here. So I can write down this as 6 pi neta RV equals to mg minus rho L, V, and G. Rho L is the density of the liquid. Say yes or no.
Yeah.
yeah,
Now, one more thing, this mass of the object, density of the object is mass of the object upon volume of the object. So, from here, the mass of the object is density of the object into volume. So, this mass of the object is there. So, I can write density of object. This is density of object. This is mass of object. Density of object into V into G minus rho L into V into G. Now this volume and this volume is the same because in this the whole object is immersed. So the volume of the object is the same as the volume of this object. So I can say density of object minus density of liquid times V and G, and here it will be 6 pi neta R V. So if I want to find out V, that is the terminal velocity, I will divide 6 by neta r on both the sides. So it will be rho object minus rho liquid capital V times G divided by 6 by neta into r. So this will be your expression. This is not given in your data booklet, but I think the examiner may ask you by just giving out the density of the object and the density of the liquid and the radius of the object. So it is a sphere. So you can also say that volume, it is given in your data booklet. You can check volume of sphere is nothing but 4 by 3 pi r cube. So if they give you R, they give you neta, they give you density of liquid and density of object, they can ask you to find out the vol terminal velocity of the object. So in the question, the experiment, what they are talking about is similar to this, what we have done. Okay. So try to read out the question and solve without looking at. Always remember the first step should be conversion of the units into their respective SI units and then apply the equation. Did you get the answer? Okay. 6 pi neta r is 8.9 into 10 raised to 4 minus 3 into V is 7.6 into 10 raised to 4 minus 2 plus rho L 842. V is 4 by 3 pi r is 8.9 into 10 raised to 4 minus 3 q. Rho V into G is 9.8. Make sure you put the brackets correctly in your calculator while solving. Otherwise, you will end up with the wrong answer. This will be equals to mg, which is 3.1 into 10 raised to 4 minus 3 into 9.8. So we have everything in this equation except the neta. So I would recommend you to solve this separately, write it down, solve this first, write it down, solve whole this 6 pi and whole with this and write it down. And then it will be easy for you to substitute the value. Once you solve in your calculator, you will get something around 0.47 Newton second meter square minus 2 Newton second per meter square.